Okay, so if we want to find the inverse of a function, there are four basic steps, and I like to call these like a template. A template is something that you can, a process, if you like, that you can throw over any question, and as long as you follow that process, you will get the answer. So my template for finding the inverse of a function has 4 steps. And the first one is to determine whether y equals f of x has an inverse. Now, there are, the only way you really know at this stage is to do what's called the horizontal line test, which we've covered before in previous work. So if you can draw a horizontal line, if you can graph it for a start and then draw a horizontal line, then the function has an inverse. If it's so difficult that you can't and you're asked in an exam situation to find the inverse, we'll assume that the inverse does exist, and so you can go straight on to step 2. Step 2 is rearrange y equals f of x so that you make x the subject of a formula. If you like, y equals f of x is a formula, and rearrange it so you get x equals, so all the x's on the left and all the y's and numbers on the right. So that's your next step, step 2. Step 3 is to interchange x and y. Where you see an x, you put a y. Where you see a y, you put an x. And then that will translate into the inverse function. So I'll do an example straight after this to explain these in a little bit more detail. And then the 4th step is a verification process where you do the composite function of the inverse and the actual function, and that should bring you back to x. So that should be exactly the same here. So don't forget, functions are like mapping, so you map x onto f of x, and then the inverse should bring the point, all points back to the original, which is x. Okay, so they are the 4 steps of my template. Let's see how they would work. So the question may be find the inverse, and this is in your notes, find the inverse of y equals x plus 1 over x minus 2. Now this is my f of x. So what we've got to do is find the function that maps this function back onto x itself. So the first step would be to determine whether it has an inverse. Now that's not too hard to graph, but it may be beyond people to do an accurate graph of that. If we're in an exam situation, we could assume that that inverse function exists. What does this look like? Well, you can see that the function is undefined for x equals 2, because we'll have divisibility by 0 if you put a 2 in there. So x equals 2 looks like that. And the graph is undefined there, so the graph's not going to cut that point. Likewise, when y equals 1, we also have a point where it won't cut, so y equals 1 won't cut, so the graph would look a little bit like this. Now, there is nowhere you can draw a horizontal line where it's going to cut the graph twice. So f to minus 1 of x exists. As I say, if the graphing is a bit beyond you and you're asked to find the inverse, we can assume that it does exist. Number 2, make x the subject of the formula. So we've got y equals x plus 1 over x minus 2. Now, we've got to rearrange that to get x equals. It's particularly difficult when you've got a fraction on the right-hand side here. So I'm going to do a thing called cross multiplication to get rid of all the fractions on the right-hand side. So we multiply the top here by the bottom there, and we get y outside of x minus 2. That implies x minus 2 equals 1 outside of x plus 1. That's a cross multiplication. We cross the numerator by the denominator. the denominator by the numerator. Remove brackets and we get xy minus 2y equals x plus 1. Now we want to get all the x's over on the left here, so we get xy minus x, and if we're getting all the x's here, we'll get all the terms containing y over here. We can't get that one at the moment, but we will in a minute, so that minus 2y goes over there, will be 2y, and then the plus 1 just stays on the right there. We can factorise this now and get x outside of y minus 1 equals 2y plus 1. And if we divide both sides by y minus 1, they will cancel, and we get x equals 2y plus 1 over y minus 1. And you can see here y equals 1, y equals 1. This function is not defined, so y equals 1, the graph won't cut that as well. Alright, so that's just going back there. So we've done the second step now. We have made x the subject. So we've got x's on the left and all terms containing y on the right. My next step is to interchange in my template, interchange x and y. So number 3, interchange x and y. Well, that's pretty easy. Where there's an x, I put a y, and where there's a y, I put an x. So it'll be 2x plus 1 over x minus 1. So f to the minus 1 of x is equal to, we think that the inverse function will be 2x plus 1 over x minus 1. Alright, so we think we have found our inverse function, and we need to verify that, because not every time that you find the inverse will it actually be the inverse. When you do the verification, you'll find sometimes that it will not hold true. So my first step is to show that f to the minus 1x is equal to x. So that's f to the minus 1x. And we're going to hopefully show that that's all going to be equal to x. Now, one way of looking at this is to actually put down what the actual function is. So this one that's outside the bracket, and the original function is x plus 1, so it'll be something plus 1 over something minus 2. That's what the function is. The original function would be, it says get something, add 1, and divide that same something to minus 2. That's what it is. Now, what is that something? Is the inverse function. What is the inverse function? Is 2x plus 1 over x minus 1. And this is the same, 2x plus 1 over x minus 1. Now, we're hoping that that's going to be equal to just x. Now, how do we cope with this? We've got our vinculum here. We've got to add these two fractions. Now, that's not a fraction at the moment, but we can make it into a fraction. Any whole number is just over 1. And as you know from your knowledge of fractions, that you're going to make both denominators the same. Well, this denominator is still just x minus 1. So how do I make this with a denominator of x minus 1? Just multiply top and bottom by x minus 1. So if we multiply the bottom by x minus 1, we've got to multiply the top by x minus 1. All right, that will all cancel down to the number 1, which is what it was there. Same thing on the bottom. We got 2x plus 1 over x minus 1 minus 2. Now that's like over 1, so it'll be 2 outside of x minus 1 over x minus 1. We have now got the same denominator, so we can add the fraction. So here's my big vinculum, this one here, and we've got x minus 1, and we've got 2x plus 1. So now we've got the denominators the same, we can just add the numerators. So it's 2x plus 1 plus x minus 1. And the bottom is the same, however, we've got 2x plus 1 on there. Now this minus, we've got to be very careful with that. We've got to actually change signs inside the bracket. So That minus, when we multiply by the 2, don't forget the 2 is going to be multiplied by both of those, so that'll be minus 2x. Now that minus will make that minus into a plus, so it'll be plus 2. Now this can be seen, this vinculum in the middle, the big one, is like a divide by sign. So we've got a fraction divided by another fraction. How do we cope with that? We change the divide by to a multiply and we flip this second fraction. Okay, so let's just simplify the numerator here. We've got 2x. Now the plus 1 minus 1 will cancel each other out. And we've got 2x plus 1x. So that's 3x over x minus 1. Now, as I said, this was a divide by. We changed this divide to a multiply, and then we flip this fraction upside down. So when we flip, the x minus 1 will go on top. And now we can see if we can collect some like terms here. We've got plus 2x minus 2x, which is 0, and then plus 1 plus 2 will be over 3. These will cancel. X minus 1 goes into itself once. 3 into 3 goes once, 3 into 3x just goes x, or 1x if you like. And when you multiply out the numerator, you get x times 1, so that'll be x and over 1, which is equal to x. All right, so that's that one. I'm not going to do the second verification. The second verification is f to the minus 1, f of x. I'll get you started. The inverse function we think is 2 times a number plus 1 over something with a number minus 1. So that's the inverse function. That's what that is. Now what goes in this bracket here is f of x. What is f of x? If we go up to here, the f of x is x plus 1 over x minus 2. That's the original function, x plus 1 over x minus 2, and that's the same. And then it's a matter of going through and doing a similar process to what we've just done here. And when that'll take a couple of lines and you should get down to x. So if you want to have a look in your notes, it'll tell you step by step there. So finally, we quote that if f of x is equal to x plus 1 over x minus 2, f to the minus 1 of x is equal to 2x plus 1 over x minus 1. So that is the inverse function.